Okay, today we're going to focus on the scientific approach, which a lot of you know referred to as a scientific method. And you kind of use the scientific method in one way. Maybe one point in your life, maybe you've been caught in the rain, and the question is, should you run or should you walk? Will you stay drier one way or the other? Because if you think about it, if you run, less time in the rain, right? Less water falls down, you're outside less, you get underneath something to protect yourself. Maybe if you walk though, moving slower causes you to run into fewer drops as you're going, horizontal on the ground. So we could actually look at this and use a scientific approach to solve this. So thinking about this, you remember learning about the scientific method. The scientific method is a good way to organize and gather information and communicate information to answer a question. So that's a good definition for the scientific method. Also, let's look at the steps. So if we were going to go through this, here's the first step. You ask a question. Which way will I stay drier while it's raining? I develop a hypothesis. I got to pick one way. I'm going to say running's better, less time. That makes sense. Then I'm going to test the hypothesis. I come up with a set of directions or ways to test it on a scientific level using quantitative data, numbers. Then I'm going to look at the numbers and I'm going to make a graph possibly so that I can compare the information. And then I have to make a decision. Was my hypothesis right or was my hypothesis wrong? And it's okay either way. It doesn't really matter because then I can go back. If it was supported, that's great. Maybe I should do it a different way just to be sure. If it's not supported, I go back up here and come up with a different idea, a different hypothesis. Here's an example of the scientific method. And basically it's fully completed and I can develop a third theory. Observations are important. Like I said, it's information you get through your senses. Hypothesis is a proposed answer. You probably heard it possibly as like a good guess, but it's not really a good guess. It's well thought. It's more than a guess. It's researched. So, for example, when we test a hypothesis, we got to look at a few things. First of all, the manipulated variable. The manipulated variable is going to cause change. So, the speed at which I run. The respondent variable is changes in response. So I can measure how much my clothes, the mass of my clothes, because the mass of my clothes would be how much water they soaked up. A controlled experiment is an experiment in which only one variable, the manipulated variable, the speed at which I travel, is changed. We don't want to change everything. We only want to change one thing. That's a controlled experiment. So I'm going to draw conclusions. And I'm going to possibly come up with a theory. Now, what's the difference between a theory and a law? Well, theory, it says, is a well-tested explanation. A lot of observations, a lot of results, and it's beyond a hypothesis. Other scientists have worked on it together, and it explains something really, really well. And some people think that a theory is better, or excuse me, a law is better than a theory. That's not really true. Actually, theory does a little bit more for us, or at least different things for us. So for example, a law doesn't do any really explaining. A law is going to go ahead and predict. So you can kind of see, going back to these things here, these are some examples. Now in 1997, which is a long time ago, 2 meteorologists actually went ahead and did this to figure it out. They said, what is going to keep you drier? And they did 100 yards, ran the same distance, same type of clothes, same amount of rain, and the clothes of the walking scientists had 217, where the clothes of the running scientists had 130 grams. So the running scientists actually, their mass was lower, which means running in this case is going to keep you drier. And again, like I said before, though, is this time for a law? Should they come up with a law? If you run, you'll always stay drier. Well, remember, a law only predicts, and a theory is going to explain. the law of gravity explains what happens during when you have an object close to Earth. It doesn't explain why. Keep that in mind. The theories, though, like the theory of evolution, is very descriptive. It explains a lot of different things at both the microscopic and macroscopic level. Scientific law, again, summarizes what we know and then predicts. That does not explain, because it can't be explained yet. We don't know why gravity works, it just does. Which is tough to understand, but that explanation is a pattern that we can hopefully explain in a theory at some point. Models are important. Sometimes seeing and hearing and smelling and tasting and using your senses to understand science is not possible. Maybe it's too big or too small situation. Maybe we can't travel there. So what we do instead is we make a model. A model is going to represent things. Now, I can't get in a plane above the United States and be able to see where all the rain is, but we can use weather maps that are created by satellites to help us understand this is a model. It's not the real thing. It's not real rain. It's a model of what's going, so it helps us understand. Another example would be something maybe you made when you were in elementary school, the solar system. It helps us visualize it. We can't fly over the United States and see exactly where it's raining. Also, we can't go out and understand the solar system because it's too far away and way too big. So we can make this mental picture right here, which is great. And pretty fun, really. Working safely is another thing we've considered, just like we can't go flying into space. Well, when we're observing things here in the lab, we need to stay safe and wear personal protection equipment. What is a hypothesis? Well, a hypothesis would be D, a proposed answer to a question. The rest of them aren't very good answers. How does a law differ from a theory? We talked about this a little bit. A scientific law describes observation while theory provides an explanation. The describing the observation is more of a, if this happens, then this will happen. It's a prediction. Well, there's an overarching explanation on a theory. What is the main purpose of scientific model? Basically, so we can say that we understand something that's very complex, because it's hard to understand something that's unsafe or large. How does a scientific law differ from a theory? Again, ask your teacher or check the procedure to find the correct safety precautions. That's how we could look at that and say that we're being safe.